Generic code enables you to write flexible, reusable functions and types that can work with any type, subject to requirements that you define. And you can write code that avoids duplication and expresses its intent in a clear, abstracted manner. Hi, my name is Stewart Lynch, and in this video we're going to take a look at how you can get started writing your own generic, reusable functions. We'll cover the basics before we explore a couple of different practical examples. Now before I get started, please leave a comment below if you enjoy the video, and give it a thumbs up, and subscribe to my channel. Make sure you ring the bell to be notified of new videos. So if this is something you want to learn, then keep watching. For this tutorial, I've created a starter project, and you can download it from the link provided in the description below. It's a playground with multiple pages, and, as with all my videos now, I utilize a shared function found in the sources folder that'll help me keep my examples separated. Just keep your code for each example within the code closure, and you'll see your output nicely separated in the debug pane. Now before we jump into more complex examples, I'm going to start with a pretty standard example that is used in many explanations of generics in Swift. I want to create a function that prints out the sum of two numbers. First, let's create a function called add that has two parameters, both ints. In the body, we can then just print the sum. So we can call that function with the two parameters like 15 and 17 and execute our playground. This prints out our total of 32 in the debug area. Perfect. But what if we try that same function and use 12.4 and 15.2 as the arguments? This time we get an error that it cannot convert the value of type double to the expected argument type of int. Our argument types don't match the type specified in our function's parameters. Let's introduce a generic type now then. First, we'll copy and paste from the first example into this next code block. Swift can infer a type of an object that you pass in as an argument to a function. We never, when calling the function, specify that we're passing in an int in that first case, or a double as with the second. Swift inferred it, and when it saw a double coming in when it was expecting an int, it said, wait a minute, you can't do that. What we can do is introduce the concept of a generic type, meaning that the function will accept anything you throw at it, and will try to deal with it as it comes in when trying to manipulate the arguments in the body of the function. When you use generics, you have to specify a placeholder that will represent the type. It can be basically any string of alphanumeric characters, but the standard adoption is to use a capital letter T to represent the type. And we do this when defining our function right before we declare our parameters, and we enclose it in angle brackets. And then for our parameters, we can replace the type with that placeholder. This produces an error message, however. It's telling me that T must conform to the range replaceable collection protocol. Actually, this error message isn't too helpful for us. What it's saying is that in order to use the plus operator between two generic types, it must conform to this range replaceable collection. Now, if I check out the documentation on this protocol, it looks like what I need is something that is an array of objects or strings, which you can specify a range for or create a subsequence from. In our case, however, we don't want to use that particular function for the plus operator. We simply want to sum two numbers. So instead of saying that our type must conform to the range replaceable collection protocol, we want to be able to specify that we're expecting a number, and there happens to be a numeric protocol for this. So after we declare our type, we can do the same when we are adding our conformance to a struct or class. We just enter the colon followed by numeric, and then the error goes away. Now let's copy and replace both of those functions from the first example now and paste them in here, and I'll remove the comment on the second one. This time when we run, we don't get an error, we get our result printed out whether we pass in an integer or double. Now what would happen if we tried to pass in two strings, like add, Stewart, Lynch? It won't allow us to do this because now we have a requirement that our arguments must be numeric. For the next example on this page, we want to create a function that will add two strings or two arrays together to form a single string or array. We could call this add as well, so let's just copy that function again, but change the conformance. This time we'll remove the numeric requirement, and we get that error that tells us it has to conform to the range replaceable collection. So let's do that. And since we're no longer dealing with numeric values, let's change our argument names to something like arg1 and arg2. Now, if we copy that failed example from the last one and run it here, we'll get our two strings joined together. Let's try two arrays. For example, add an array 1, 2, 3 and a second array 4, 5, 6. When we run this, we get the joining of our two arrays. Now, one more thing before we move on to more complicated generics. What if we want a function that would accept any number of numeric items and print the sum? For this, we can create a function that uses generics. So in this case, we'll specify t again as conforming to numeric. And for our function argument, we can specify our numbers are a variadic set. So numbers, t, ... For the body of the function, since we have a range, we could loop through the numbers starting at 0 and adding 1 to it. But a sequence of numbers has a higher order method called reduce, where you can specify the starting number, which is 0, and simply the operator, which is plus. Now we can simply call this function by passing in a range of numbers, like 1, 2, 3, 4, 5, and 6, and then print them out, and we'll get our sum. Now the nice thing about functions, and it really doesn't have anything to do with generics, but you're allowed to have two functions with the same name so long as the parameters are different. For example, for our two numeric examples, we have two generic types as parameters, while this one has a variadic parameter. This means if I copy and paste both functions into example 4, Xcode won't complain about it. I couldn't copy in the range example because it has the same arguments as the second example. Now, when I invoke this function, I see that I have two options, one requiring a range of values, while the other just 2. Of course, with the second function created now, this first one is redundant, because we could have simply passed in 2 values with that variadic version 2. A large majority of apps require interaction with some back-end server, and the data provided by the server is most likely in the form of JSON. Now, I have an entire series on decoding JSON, and I'll leave a link in the notes below. For the purposes of this page, though, I've simplified matters, and I'm retrieving my JSON from files stored in my app bundle. And in a playground, we can use the resources folder for storing those files. And you'll see that I have 2 files here. One called goals.json, and it's an array of JSON objects, each with 4 key value pairs. I've also created a corresponding source file called goal, where I have a struct into which we wish to decode our JSON. It conforms to the Codable protocol, so we should be able to do this. Similarly, I have a file called resources.json that is also a JSON array of objects, each with 4 properties, and a corresponding file with the struct definition, which is also codable. Note that in both cases, we've made our structs and its properties public. Now, normally you wouldn't have to do this for your projects, but because in a playground the sources folder is considered a separate module, you need to specify the access level as public so that your playground can access it. And I have a video on this topic too if you need a refresher. Again, I'll leave a link in the description below for the video too. So back in our decoding and generics playground, let's take a look at this first example. I've created a pretty simple function that fetches our goals from our bundle, and upon a successful decoding of the data, executes the completion, which is a function that has an array of goal objects that we have just decoded as the function parameter. So if I want to print out the name of every goal, we can run this function. When we create the function, we can hit enter on the completion handler, and we see that we do indeed have a placeholder for an array of goal. So we can assign a variable name for this, say goals, and then loop through the array, printing the name each time. Executing the playground displays the correct results. Now this is pretty straightforward, as I said. And I go over how this function is created in that Codable series I referenced earlier. The issue is, though, I want to use this same function, but not have it bound to the goal type. I want to make it more generic. So let's copy that function into our next code block and see what we can do. The first thing I'm going to do is declare that I'm going to be using generics by specifying a generic variable t for our function, and replace each instance of goal with t as well. This generates an error that says we require t to conform to decodable. Now, Codable is just a type alias for decodable and encodable, and our two structs conform to Codable, so we can safely add this conformance to our generic placeholder. The error goes away, but I have two other problems with this function. First, our URL variable is named goals_URL, and it's always going to try and decode from the goals.json file from our bundle. So let's add a new function parameter that we can pass in a file name, and that will be a string representing the file name without the extension. And then I can change goals URL to JSON URL for bundle.main URL and use file name instead of the hard-coded goals. Let's also change goals data to JSON data and make sure that we have all those references updated. I'll also change goals to result and rename the function fetchData. Now this will work for our solution, but it's always going to expect an array of our generic objects. In real life, your JSON may be one big object, so instead of having an array of t for our closure argument, let's just use t. And we can change our decoder to just expect t. This is much more generic, and it'll cover the majority of cases. I've simplified this somewhat, as I'm assuming that the date and key decoding strategies for our decoder are the default ones, and this will likely get you in trouble in a real fetch of JSON containing dates. So please watch the decoding series for more information on that. Adding a key decoding and date decoding strategy won't change what we've done to make this generic, however. So let's test. I need to pass in a string for a file name, so let's use resources, so that we can fetch and decode our resources JSON. Now for the completion handler, it's specifying that the argument must be decodable, and that's all. As the error says, it's unable to infer the type of the closure parameter. Remember, it can either be a single object or an array of objects that we expect. So we have to tell our closure argument what to expect. Since we know that our resources JSON file is an array of objects that we want to map to a resource type, we can specify our variable name as resources, but also specify that we're expecting it to be an array of resource. And now we can loop through that data, printing out our resource name. which is just the property resource. Running this in the playground, we get our results displaying the resource name for each of our resources. Similarly, we could now use this same function to get all of our goals. I just need to specify that the file name is goals and that our closure parameter is expecting an array of goal. And then I can just loop through all of the items, printing out the goals name. It is common practice, especially with SwiftUI, to provide mock data for any models you have so that you can present your views in the Canvas previews. This helps you to build your previews with sample data. For this playground page, I've added to our goals and resources struct by adding an extension for each. In each case, I've added a static property called mock data. That's an array of the corresponding structs along with 4 or 5 array elements. These variables have been made public for the same reason as before, since we are in a playground and the sources folder is considered in another module. Now, as an exercise here, I've created a function that is incomplete. What I want to do is to sort the goals mock data by name and then use the sorted array as the completion argument. I can use the sorted method on an array to sort on one of the object's properties. And I cover sorting in my higher order functions video, so if you need a review, I'll leave a link in the description below for that video. Now, since mock data is a static property of the type goal, we can assess it like this and perform the sorted method by comparing subsequent names. Now I can call that function, and I can see that our completion argument is an array of goal, so I can loop through the elements and print out the names. Now, as you can see, this is just specific to the goal type, and we want to make this generic. Well, we're adding more restrictions now. What are the problems? Well, we'll need to assure that our structs have a static property called mock data. And also, our resource model doesn't have a property called name, so we can't make this sorting generic, because how can we do that if our model doesn't have a name property? So how do we solve this problem? First, let's ignore the sorting requirement and simply create a function that will return our mock data from the struct. So here's what our sort mock data function would look like with that removed. Let's go ahead now and make it generic by adding t as our generic placeholder. So again, that requires specifying t in angle brackets before our function argument parentheses. And we replace goal with t. Now, this gives us a couple of errors. But the first one is that t has no member mock data. And this makes sense because t could be anything. And what we want to do is make sure that if we're going to call this function, our class or t better have some mock data. Now we can force this issue by creating a protocol that our structs must conform to. And that protocol will specify that conformance requires a static property called mock data. So in our sources folder for this playground page, create a new file called protocols. And in it, we'll create a protocol named mockable. And again, once more, we better make it public. What we need to specify now then is that any class or struct that conforms to this protocol has a static property called mock data. But we also need to specify its type. And it can be anything, like in our case, either an array of goal or an array of resource. So how can we solve this? Well, we create a placeholder here too. And since we're specifying elements of an array, it's common practice to use element as that placeholder. And we do this by specifying it as an associated type for our protocol. And then we can specify an array of element as our type for mock data. And then we also have to specify whether or not we are going to be getting or setting or both in this array. Now we only want to get So that's all I'm going to specify here. Now we can go back to each of our two structs and make sure that they both conform to mockable, which they do because they both have a static property called mockData. I'll add this conformance to the extension for both. Now you're going to get this error, cannot find mockable in scope, show up regularly here. This seems to be a phantom error. It's just Xcode not catching up with saved files. Since we made that protocol public, it most certainly can be found by this playground, and this error will go away. Now, back in our playground, we can specify that our function's generic type conform to this as well. We're still getting an error, however, as it can't convert the value of an array of t.element into an array of t. So we'll need to cast this as an array of t. And then because it's optional, we can use if-let and complete with our now unwrapped mock data. Else we can complete with an empty array. Testing this now with resources, we can see that the closure argument cannot infer the type. So we'll need to be specific and specify that we're expecting an array of resource. And then we can loop through and print out the resource name and perhaps the resource's link or author for the resource. Great, it's working. Let's just create a separator string here and check for goals too. Let's create a loop and print out the goal name. Okay, now that we have this working, we can finish up by looking at the sorted dilemma. The problem is, as you may recall, that our two structs don't have any property names in common other than the ID, and that wouldn't be a good property to sort on. What we can do though is, within each struct, define a default sort order, and we can do this by specifying that the struct conform to comparable. If you let Xcode generate the stub for you, you'll see that it's a simple function with the less than operator that requires you to provide what properties you want to compare. So for goal, we can use name. If we go to resource, we might want to have the default sort be on the resource property, for example. So again, we'll conform to comparable and generate the stub. Then we'll do a similar thing as before. We'll make the left-hand side dot resource be less than the right-hand side dot resource. Back now in Playground, we'll take advantage of the fact that our two structs conform to comparable and add that requirement to our generic function. And we do that by using the AND in our type specification. With that, we can now sort our data before running the completion. And we do that simply by calling the simple sorted method without any arguments to specify the default. And that's done at the class level as we've just defined. This time when our Playground runs, our resources and goals are sorted by that specific property. Well, there you have it. Some practical, I hope, examples of using generics in your code.